We're going to go ahead and talk about absolute value inequalities, and the first portion of this will be on conjunctions. So a conjunction is what we call an and statement, and that means that our answers or our solution set is between two different numbers. So if you think about kind of how we did like domain and range, when an answer is between those two numbers, we say that it's less than one number, greater than another number. So this is the format that it usually takes. Number is less than x, less than the number, because this is bigger than this part, but it's smaller than this part. Okay, so the same thing happens with the absolute value. And because we're thinking about negative and positive counterparts, just like with the equations, this will generally be our negative side and this will be our positive side. So x will be bigger than the negative, smaller than the positive, and I'm speaking generally, okay? So it's not always going to be just negative and positive. So if you have no idea what I just said, let's just go to the examples. Okay, that's the best way to demonstrate. Okay, so this is our first example, and I'm going to put here on the side what this is the same as. So this right here is the same as saying that negative 8 is less than or equal to, well, that whole absolute value part. Okay, so 2x plus 5, which is less than or equal to 8. So if you kind of look at what I did up here, when I said that whole negative part, so the negative portion is here, the absolute value part's in the middle, and the positive number is on the end. And it follows that same pattern. Okay, and this is just going to help me solve the inequality. There's a way to do this all at once, however, it's a little confusing, so I went ahead and split it up into two parts. So for the negative portion, okay, so for this portion here, this is over here, and I always start with the expression first. So since I flipped it over, I have to flip the sign, okay? The positive portion is going to be this piece right here. So this one is exactly as we see it. Okay, so I'm going to go ahead and solve them real quickly. So subtract 5 from both sides, which gives me 2x greater than or equal to negative 13. Divide both sides by 2. Okay, and so x is going to be greater than or equal to negative 6.5. And you can leave it as a fraction. I'm going to go ahead and do the decimal just so we have an exact number of what we want. Okay, do the same thing for the positive side. So subtract 5. So 2x is less than or equal to 8 minus 5 is 3. Divide both sides by 2. So x is less than or equal to 1.5. Okay, so now that I have both answers, because these are absolute value inequalities, we have to graph it and see what all our answers are. Remember that with inequalities, we don't have just one answer, we have what we call a solution set. Okay, so I'm going to plot 1.5. It is a closed circle. Both of them should be in this case. And, oh, I'm sorry, this should be negative 6.5. My bad. So negative 6.5, and this one is 1.5. Okay, I'll make that a little bit nicer. Okay, and we're going to see if our answer looks correct. Okay, so both of them are closed circles. And let's see, we have x is greater than or equal to negative 6.5. So that means that if x is greater, remember our solution set is x, that means that we'd be shading somewhere in here, okay? And x is less than 1.5, so that means we'd be shading somewhere in here. So this graph does fall into what a conjunction should look like. Remember, a conjunction should be all the numbers between two numbers, okay? Which means that our solution set is correct. So I'm going to go ahead and write it officially. Let's use a different color. Let's use yellow. So my solution set for this particular absolute value inequality, okay, solution set, is going to be that negative 6.5 is less than or equal to x, less than or equal to 1.5. And this right here is our answer. Okay, Let's go ahead and try one more. So in this problem, we have a number on the bottom. Remember that whenever we deal with absolute value, solving anything, we do have to isolate it first. That means I'm going to have to get rid of that 2. So before I do anything, I'm going to multiply both sides by 2, and that gets rid of this for me. So now I have negative x minus 4 is less than or equal to positive 6. Okay, so just like before, I'm going to go ahead and split this into my negative and positive. So negative would look like this. Negative x minus 4 is greater than or equal to negative 6. Okay, and the positive one is negative x minus 4 is less than or equal to positive 6. Okay, so I'm going to solve both of these. So I add 4 to both sides. Negative x is greater than or equal to negative 6 plus 4 is negative 2. I divide by negative 1. Remember, there's an imaginary 1 here. And I get that x is going to be something here, positive 2. Okay. Now, I said something because a long time ago in Algebra 1, you learned that when we divide or multiply by a negative, when inequalities are involved, we have to switch this. So this is actually going to be less than or equal to 2. Okay. That's my first answer. Let's go ahead and do the other side. So add 4, add 4. I'm not going to put the line this time because it looks a little messy. So I have negative x is less than or equal to 10. 6 plus 4 is 10. Again, divide by negative 1, which gives me x is greater than or equal to negative 10. And again, we have to flip because we're dividing by a negative. So right here we flipped, right here we flipped because of this division by negative 1. Okay, so let's see if this makes sense. I have 2 different signs, which is good. So let's go ahead and make our little number line and see if it works. I'm going to plot negative 10 first. Make sure I do it correctly this time. And positive 2. These are also both closed circles. Okay, let me get a different color for the graph part. I have that x is less than or equal to 2. That means that I can shade everything that's over here. So I can shade everything that's less than 2. And I have that x is greater than negative 10. So that means that x is bigger than this number. So I can shade everything that's in here. They meet in the middle, which is exactly what a conjunction is, which means that my answer is correct. So I'm going to go ahead and write my solution set. And I better do it quickly before the time runs out. So my solution set for this one is that negative 10 is less than or equal to x, which is less than or equal to 2. And that's it. Okay, quick reminder, this is conjunction, absolute value inequalities. Our format should, in the end, look like one of these two, okay, where the number is sandwiched between 2 different values. Those values represent in the middle our solution sets, okay?